Awesome. So we are live. Hey everyone, welcome to Local Stack Community event for April. And I'm really looking forward to the talks today because in the previous community events, we've discussed about features, enhancement, but this time we are going to learn about how Local Stack is building Local Stack using Local Stack. So, and then along with this, we are going to learn about how you can test your cloud applications in CI. So it's going to be amazing. But before we move ahead, I would love to meet our amazing speakers. Yeah,
Hey
awesome.
there.
Hey, hi, Lucas. Hi, Harsh. How is it going for you? I mean, could you introduce yourself, Lucas?
Going good, yeah, thank you. My name's Lucas, as you might have heard by now, and I've been working at LocalStack for 2 years now as a full stack engineer, mainly focusing on the web application, and hence I wanted to give a demo and present on how we ourselves are using LocalStack to build LocalStack.
Yeah, Lucas loves dog food feeding. Definitely. Looking forward to it. Harsh, over to you. Could you please introduce yourself?
Sure. I guess my name is Harsh, and some of you who might have been attending these community events, you might have seen me kind of moderating and hosting these meetups quite many times. But I guess that baton has passed over to Nancy right now, which I'm really happy about. So thanks a lot for joining the session today. I guess I'm giving one of the meetup talks maybe after a year by now. So I will be talking about how you can use LocalStack in your continuous integration pipelines because this is something that our team has been doing. So kind of building sample applications, integrating continuous integration pipeline, and making sure that we have a really strong coverage across the major CI providers. So we are gonna kind of present the work that we have done so far and also present a really small tutorial about how you can also use LocalStack in your CI itself. So I guess over to you, Nancy.
Yeah, I mean, yeah, I was just going to say it's always good to be on the other end.
Yeah.
Yeah, so thank you so much, Harsh, Lucas. Looking forward to the talks. With this, I just want to, because I skipped the agenda, we already did the introduction and welcome. We met our amazing speakers. So I'm going to do a bit of announcement regarding the release, and then we are going to have building local stack with local stack talk, and then we are going to have using local stack in continuous integration pipelines. So in between, if you have any questions, you can use the YouTube comment section. And if you want to put anonymous questions, so you can use slido.com, you can scan the QR code or use the code which is given on the screen. I'll also put this in the YouTube comment section. So yeah, feel free to ask the questions. Let's make it more and more interactive. And if you're joining for the first time, the community event, let us know in the comment section. Awesome. So with this, we have released 3.4.0. That is amazing. And if you want to read about the announcement, you can check this link at Discuss. And yeah, this is here with new features, enhancements. It includes AWS feature updates such as Lambda support for Ruby 3.3, and also there are many other things. The highlights are, one of the highlight is new experimental event rule engine. So with this, there is this content filtering. You can write complex event patterns that only match events under very specific condition. And the following service currently use the event rule engine, that is Event Bridge and Lambda event source mapping. So you can check this out. And then we have new features and enhancement. Like one of them is support for Kafka version 3.6.1. There are new app sync features, new IoT features, support to new APIs, and more. So you can read more about this on GitHub release or Discuss post. And then we have some updates in our local stack web application. We have Neptune resource browser. So it features CRUD support for Neptune databases and clusters. Then we have Cost Explorer resource browser, which you can see in our web app. It's support for cost category definitions. We also have account management resource browser. So you can basically it supports managing primary and if you have alternate accounts via UI. And then the last one is Route 53 resolvers. So it supports for managing the resolver endpoints via UI. So you can check this out as well. And moving ahead, we have Lucas, who is going to share more about what he loves. dog feeding, and he's going to share how did we build local stack with local stack. With this, over to you, Lukas. Yeah.
Exactly. Thank you so much for the introduction, Nancy. I'll take over and talk a bit about how we are building local stack with local stack. So before we get started, I'll jump right in and talk about the software development lifecycle that local stack wants to support from start to finish. So typically that starts on the developer machine with local development and testing, moving on to CI pipelines where you can run your integration test suites. Now, a new feature that's been released with 3.0, which will enable acceptance and end-to-end tests. And last but not least, everything is moving to production, to the real environment. So now the question is, how are we doing all of these things at localstack? Well, we are using localstack to build the localstack web application, which means that if you're not familiar with the screenshot on the right, it's a web application which allows you to create your localstack account, get your localstack subscription, and then do and use cloud dev tools on the web app. For example, we have the resource browser on the web application. We have tools around chaos engineering and policy streaming. You can manage extensions from the UI, and you can also interact with cloud pods, like inject them into your running localstack instance or create a new one from the currently running one. So how do we manage to use localstack for that? Well, let's take a top-down view at our application. Our web application is comprised of two components, which are here on the right-hand side in the boxes. On the left-hand side, we have the web application. The web application is your run-of-the-mill React application, which is served through Route 53, CloudFront, and S3. And then, as all newer web applications, you have an associated or related backend. And our backend is implemented in Python, and we are using Flask for the API itself. And among those, we also use various services. So we don't only have a Flask application, but we also make use of AWS services like Lambda, SNS, SQS. We use S3 buckets for storage. We use Cognito for user management. We use EC2 and ECS as well for serverless resources. And then DynamoDB for storage and Secrets Manager for secret storage. So how do we use that or with localstack? Well, let's start with the first step here. Let's keep it simple and small. Local dev and testing. Where does localstack help us with developing the backend? And on the left-hand side, I have listed all of the various things which we will talk and go through. First is Bolt3 configuration. Then we'll take a short look at development and testing. Deployment and testing. Then we'll look at development and debugging. We will see how we use localstack extensions. And then last but not least, how we use cloud pods to enable local dev and testing. So baby steps. Bolt3 configuration. What is it? Why do we need it? Well, at the heart of our backend, we have a Python Flask application, which in production should talk to the real AWS cloud, and during development, talk to localstack. And we achieve that by using a configuration management tool called dynaconf, which allows to specify various settings. And in this case, we are specifying the default for the AWS endpoint URL to an empty string. And during development, we pointed to localhost.localstack.cloud. And that means that when we instantiate a AWS client config, we read the endpoint URL from our settings file, and we can be sure that during production, it will connect to AWS, while during development, it will connect to localstack. Cool, but that's not all, right? So that's just achieving that we can connect to DynamoDB, for example, from the Flask application. What else is there? Well, there's lots of lambdas, as you've seen, right? There's lots of ECS there, there's EC2 serverless resources. And for that, we're using CDK in production. So our whole backend is built with CDK in mind, which allows us to deploy our application to production. And we are also able to deploy everything to localstack during development times. And on the left-hand side, you can see I've included two screenshots. The first one is a make target called deploy local, which uses CDK local to deploy the whole stack to localstack. And on the second screenshot, you can see that it takes a little amount of time, almost a minute, to deploy the whole application locally, which is great because once everything is deployed and wired up correctly, we can write and run integration tests. So for this example, I have included the sign-up flow, which typically includes the API response. It includes persisting an entity incognito, and it also includes sending of a mail to confirm the account creation. So on the right-hand side, you can see a small example, which first uses requests, a Python library to post a request to the sign-up endpoint. Then we check whether the response is successful and whether the ID is not none. Then we fetch, or we try to fetch a user from Cognito with that email and assert that it's not none. And last but not least, we list messages of the SMTP server and verify whether the subject reads local stack account activation. And with these three steps, or two steps rather, so first pointing both of three to localstack and also deploying everything to localstack, this is made very easy because it's just plug and play. You can click on run the test and it connects to your locally running instance and can verify whether all of these assertions hold. For the concrete development and debugging, we make use of two very exciting and cool features. So one of them is Lambda hot reloading, which I tried to depict on the right-hand side, which basically mounts files of your editor, in this case it's PyCharm, into an S3 bucket that then Lambdas run from. And on the left-hand side, I've included the code snippet that's needed to enable that. It's really small. First of all, we have to create a bucket called hot reload, and then we create lambdas from that bucket. And every time we change a function code or we want to change the implementation, we do not have to redeploy the whole application, but it's automatically reloaded because of this hot reloading feature. Similarly, we have the same for ECS tasks. There's a bit more complicated, but still pretty easy. We create volumes, or just one volume, which mounts the project into the container. And hence, whenever we make changes to files on the file system, the container reads from the same files and hence can just respond with the new responses. But there's more. Local stack extensions, for example. We use them with the auto install feature. That's started with extension underscore auto underscore install. And we use both the Mailhawk and Stripe extensions, quite extensively so, because they allow us to test purchasing flows and also mail flows. So in the previous example, you saw me make asserts against the mail server. So that's where Mailhawk comes in. And it basically allows us to fetch any mails that were sent during the lifecycle of the application. And then also we have the Stripe extension, which just allows us to really test end-to-end flows of customers purchasing a subscription. So we can see whether it was persisted correctly on Stripe's end. And last but not least, for local dev and testing, we also make use of our cloud pods. So what we have in the backend repository on GitHub is an action that creates a pod on each push to main. And for those unfamiliar with pods basically take a snapshot of the state of local stack and persist it in our storage backend. So for our backend, for example, we take a snapshot of the state, which is the whole infrastructure that's deployed. And our front-end engineers can just pull that pod, deploy it onto local stack, and just focus on developing the UI. So they do not have to set up the repository for the backend on the machine. They don't have to install dependencies. They don't have to do anything. All they have to do is start local stack with the pod, and they can develop the UI against the backend that's already running on local stack. So without further ado, I would like to take you on a small demo of the locally deployed web application. So I deployed the application, both backend and frontend, onto local stack, and that's what you can see on my screen. It's served on app.platform localhost.localstack.cloud, and we can do basically everything that we can do in production as well. So I have my test account here called John Wick at localstack-cloud, and I can try to sign in. So for example, if I enter the wrong password, it tells me that we were unable to verify the credentials because that's the wrong password. But if I manage to enter the right one, I will be able to sign in. And for those of you familiar with the web application, this might look scarily familiar. So this is not production or staging or any other type of pre-production environment. This is all locally. And I can see the familiar dashboard. I can click through getting started. I can take a look at my local cloud pods. I can take a look at local stack desktop information and so on. Also features the resource browser, for example. So in this case, I could take a look at what's currently deployed on my local stack instance, sort of like Inception. And yeah, that's pretty cool, right? The whole application that we've developed all on my machine. And what this allows us to do is be really fast, right? We don't have to wait for any deployments onto production for the backend to make changes. We can do all of that locally. With that said, let's jump back into the slides, and I'll give you a few more points for discussion. We also use local stack in the next stage of our lifecycle, which would be CI pipelines. So after developing a feature locally and writing tests locally, we push our commits, as many of you might do as well, to GitHub, where we have the repositories and where we make use of github-actions to run the tests. So we make use of the local stack github-action there, which Harsh will talk more about later. We also use state snapshots with Cloud Pods during CI pipelines and also make use of the CI analytics feature. But more on that later. Please stay if you're interested in that. Harsh will do a presentation on that right after me. So stick with the talk and I'll move on to this next step in the software development lifecycle, which are acceptance and end-to-end tests. So typically when we have confidence that our new features work through the integration test suites, we want to make sure that this also hits the requirements, expectations of other stakeholders. So not from the technical perspective, but also from, I don't know, for example, sales. So by using ephemeral instances, which are short-lived local stack instances in the cloud, we can enable that. We basically create a publicly accessible instance of local stack and can then do two things with that. One of them is the application previews / acceptance tests, and the other are end-to-end tests. So for application previews, what we do is very elaborately put here. First, deploy the app onto the instance. So both the front end and the back end are deployed onto localstack. And then we can take the link that's created for this ephemeral instance and send it to coworkers or other stakeholders and be like, hey, I've got the feature you requested here. Take a look and let me know if that looks good to you or if you want something to be changed. On the right-hand side, you can see, for example, also a GitHub comment, which we use, which basically just adds the URL of the instance to send to someone else. And what this really allows us to do is to get sentiment from other stakeholders before shipping into production, which is really great because in the past we were blocking a staging environment with it all of the time and got kind of this contested dev resource because everyone wanted to display something and deploy something. And with this, everyone gets basically their own staging environment. Last but not least, we have end-to-end tests. So similar to application previews or acceptance tests, we deploy the app onto ephemeral localstack instances, then run the end-to-end test suite that we have implemented with Playwright, and then we receive the results. So another nice use case for ephemeral instances. And for ephemeral instances, I have prepared another demo. So what I would like you to take a look at is this tab here. And you will have to trust me here or look at the URL. This was all locally, but this is on an ephemeral instance. So this is localstack running in the cloud, the front end and the back end deployed onto it. And just like locally, I can now log in with the right credentials. I see the web application and I can verify that the new features hold or satisfy requirements. So I don't know, I can be like, hey, I've updated the header on the resource browser, sent at 2 p.m. and get feedback whether that's all right or not before shipping it to production. What I can also test, for example, is sign up. So I can sign up with a new mail and choose a very hard password here, and that already exists. So let's add +123 to it. And I can see that signup works on the ephemeral instance. And funnily, since the mailhog extension is installed on the instance, I can also see that I just received a new mail which asks me to activate my account. And by doing so, I can then log in. Cool. With that said, I think it's time to switch back to the slide. And I am actually at the end. So opening up for the Q&A.
Hey, Lucas. That was wonderful. We have a lot of questions, so I'm not going to waste time. We have like a lot of questions, and I think like if you are able to do it on time, that's fine. Otherwise, maybe we can take it over comments section. So the first one is how to test async integrations like API, Lambda, SQS, etc. Is it possible for me to test out the integrations end to end?
Definitely, yeah. It's also something that we test, for example. So in this case, I think one of the main questions is timing-wise, right? You would have to sleep for 30 seconds before all of that is done. But through clever mechanisms like retries, you can just continuously try and see whether the asserts hold or not. So if you have an infra which routes API gateway to Lambda, to SQS, to Lambda, to DynamoDB, you can definitely write the test case around that end to end.
Yeah. And if you have any specific question, maybe you can, I mean, if you have more question related to this topic, you can reach out to us on local stack community Slack. So yeah, the next one is, what tool was that for config management?
So we use dynaconf. It's Python specific, and it basically just allows you to configure or to have various profiles for settings. So in this case, for example, we control the AWS endpoint URL for production and development. And it's really easy, right? Because it decouples the configuration from the environment, and hence your application code stays free from that and just imports it from the settings.
Awesome. So is there any equivalent of CDK deployment to local stack for the serverless framework?
Yes, I think there is a similar deployment framework. So serverless in itself is a deployment framework, right? And we also have serverless local, if I'm not mistaken. That's called.
Yeah, I think Harsh mentioned in the comments as well that we have serverless local stack plugin.
Yeah.
So yeah, that should be helpful too.
Yeah. So it's a plugin that you install for serverless, and then you can also similarly deploy locally to local stack with serverless.
Awesome. So the next one is, can you hot reload the volumes? It looked like that. Yeah.
Nice. Good eyes there. So for volumes, it's not really hot reloading. You basically just mount the volume to your ECS task. And since you mount the directory, it basically just always reads from there. So it's not really that you have to hot reload something. It's just always the newest state of the files.
Cool. So the next one is, can local stack be utilized to simulate disaster recovery scenarios and test the resilience of application that rely on AWS services?
That's an excellent question. We currently have a feature set around chaos engineering, which basically allows you to control parameters like how likely is DynamoDB to respond with a 500 internal server error. So definitely possible with the right configuration. I would point you to the documentation on FIS or of the outages extension to learn more.
Yeah. I'm just going to put that in the comment section because it's a good question, and we have a lot of documentation around this. Cool. So aren't the tests basically just part of CI/CD pipeline?
So in our case, we are reusing the same test suite for the CI pipeline, like we do locally. So we can run the tests either locally against localstack or in the CI pipeline against localstack. And for me, for example, what I would do is I would work on my own specific feature, write a test for it, and make sure it's runnable, right? But I will probably not execute the whole test suite, which the pipeline takes over for me. So I can always be sure that the whole test suite is green, and that's what's happening in the CI pipeline.
Awesome. Then we have, can't this reliably simulate production for conducting stress testing locally?
For stress testing locally, so I would say stress testing locally is a bit hard because you're basically testing your own laptop or whatever you're running, right? In the cloud, you're going to have your own instance with a specific configuration. If you're able to replicate that locally, then you can do that reliably as well. But if you run a MacBook, it's not gonna have the same stress tolerance as your production environment.
Makes sense. I think this is the last question. Is the debugging experience the same as it is locally, and can I set breakpoints?
That's a good question. For debugging and for breakpoints, you can set, for example, for Lambdas and ECS hooks, you can set remote debugging. You can configure remote debugging ports. For example, I think PyCharm or VS Code offers that possibility. So yes, it's the same as doing it locally.
That's awesome. Just last thing, which I wanted to post. Someone posted this on YouTube comments, so it's like an appreciation post. Thank you so much, Lucas.
That's so much.
Great work. And yeah, loved it, the presentation.
Oh, thanks so
Thank you
much.
so much.
Right. Awesome.
Awesome. So, with this, let's move to the next talk, which is using local stack in continuous integration pipelines. So, I'm going to just invite Harsh. Over to you, Harsh. Yeah.
Sure. I hope I should be audible now.
Yeah. Perfect.
Awesome. First of all, thanks, Lucas, for such an amazing talk. So for people like who are not aware about this, we are actually writing a blog post together about this exact topic. So maybe this would be out in 2 or 3 weeks from now. So just keep an eye on the local stack blog publication. But with that said, thanks again for joining the meetup today. So hi, I'm Hirsch, and I would be giving a talk on using local stack in continuous integration pipelines, and basically communicating some of the work that we have done in this field so far, how we are making the CI experience better for you, and some general suggestions about how to effectively use local stack in similar kind of setup. So let's go ahead and let's talk about why you should be using local stack in continuous integration. So I guess most of the people who are joining us today have a pretty good general idea about what local stack is capable of. But just to reiterate, local stack's fundamental basis is the core cloud emulator that we provide that can emulate over 80 plus AWS services right now. So it is not just limited to basic services like S3, Lambda, EventBridge, but also more complex and intricate services like RDS or Elastic Kubernetes Service or ECS or more of such things like that. So the good part about local stack is that just like how you develop and test your applications locally, you can use your continuous integration pipeline as the single source of truth where you technically like push a commit onto your remote repository, and that triggers a workflow against which your AWS applications are deployed, like over a cloud emulator, and you get a quick validation about everything is working or not. So with the local stack cloud emulator, you can directly deploy your infrastructure as code stack. So things like CDK or serverless framework or CloudFormation or Pulumi, they can be exactly deployed, and you can have a real good validation about how valid your infrastructure as code stack really is. The second step in this is that you basically get to run your integration tests with various testing frameworks out there like PyTest or Jest. And this can basically assert that your infrastructure state has been correctly created. But more than that, with the help of the emulation capabilities, you can see how these inter-service connectivity is really working out. So for example, if you have an event source mapping between Lambda and SQS, every time you send a message to your SQS queue and that triggers the Lambda function, you can realistically test that using a cloud emulator like localstack itself. So this is very, very crucial because to actually test these kind of scenarios, you don't have to deploy like your infrastructure on the real cloud and basically wait for few minutes to maybe a few hours to get if your infrastructure is really functional or not. The third and the most obvious reason why you should be using localstack in CI is because you obviously get to mitigate any sort of unnecessary cloud cost. So just imagine deploying and tearing down your Terraform stacks maybe 10 times in a single day just because you're testing a new feature. That is very much time consuming, and that also will cost quite a lot on your cloud bill. And with the help of localstack, you basically get to mitigate that in quite a short amount of time. So to prove kind of the things that I guess I talked about just now, I'm gonna show this whole slide about how fast local stack really is. So over the past 1 year, we have been working on a project called as Developer Hub. And part of this project also involved kind of creating sample applications that we deploy both on local stack and on the real AWS cloud. So as part of this whole process, we kind of had really consistent benchmarks showcasing us some really good results. The first one was that local stack can nearly cut down the whole CI testing time by nearly 12x. So this is not just limited to individual service emulation, what I have shown on the right-hand side with things like Aurora cluster or Fargate containers or Kafka clusters or Airflow containers. It's also about how much your team is actually spending their time waiting for the CI builds to finish and how efficient you can really get if you try using local stack instead of AWS on these scenarios. The second thing that we notice is that the teams are saving quite a lot. So the saving ratio is almost 20x per month in comparison to the real AWS cloud, because at the end of the day, you're not spinning any real resources. And your testing is not just limited to maybe the unit testing part, where you just assert that the functions are working or the business logic is functional. You can actually like combine your business logic with your infrastructure logic, and you can get to test that right with the help of local stack. So this gives you like a near perfect validity about how your application will behave once it gets on the real production. And the final part is that it actually leads to an accelerated feature development because it reduces your testing environment. I guess Lucas was talking about this part where staging environments are kind of limited to one developer at a time. With the help of localstack, developers can kind of feel empowered to push their code on a consistent basis without having to worry about any sort of cloud costs or how much time it would take to test the things on a real server. So in this case, it's localstack, because the localstack's main goal is to kind of emulate the whole of the AWS cloud with as much parity as possible. So whatever you're trying to deploy on localstack, it will behave nearly the same as it would on the real AWS cloud. And you can do that without relying on some sort of a staging environment. So we have done plenty of benchmarks. You can actually go to this particular link, bit.ly/ls-benchmarks, and you can get to see our YouTube playlist kind of demonstrating how fast it is to spin individual services with localstack. So how does localstack exactly integrate with continuous integration? So over the past few years, we have been maintaining a lot of official documentation on how localstack really works with a lot of different continuous integration providers. And in most of the cases, we were just using generic drivers. So localstack in itself is a pretty easy tool. You pull the official Docker image, you install any auxiliary tools that we provide. For example, if you want to use the localstack CLI to start your Docker container, you just install the localstack CLI from PyPI or maybe the official binary. If you want to use the AWS CLI local, you can install that from PyPI and things like that. So it was really generic and you can customize it as per your needs. But we wanted to invest on something that's really official. So for this particular purpose, we actually went ahead and we started creating like official plugins for both Github-actions and Circle-ci. So if you search for setup-localstack Github action, that's the official Github action that we provide right now that allows you to have all of the capabilities that Lucas just showed you before this particular presentation. So things like starting a new localstack container in your CI runner, things like saving your infrastructure state into cloud pods, creating an ephemeral instance and deploying your application over there, simply all of that. We also have a plugin for Circle-ci that basically allows you to set up localstack on your Circle-ci runners. And as we are further fleshing out the whole support, we have generic drivers for any other CI platform. So this is not just limited to GitLab CI or Travis CI. You can technically use any of the other CI systems that you find favorable. But on top of this, we also have new add-on features. And these features are things like cloud pods that basically put, like I basically call this as a like Git for infrastructure, because it allows you to take a snapshot of your cloud infra. You can share it with your team members. You can really collaborate with them and you can get to see how things are really working. We have got CI analytics that basically allows you to drill down on your CI observability. So look at things like how was local stack behaving when your infrastructure was being deployed, or what are the request and response traces for each and every API call that was being made while it was interacting with local stack, or things like ephemeral environment that basically allows you to have a certain degree of acceptance testing. And as it was reiterated, our vision is to support the entire breadth of cloud software development lifecycle. So with the tools that we're building, so things like outages extension, for example, you can also do chaos testing right on your continuous integration runners with the help of localstack. Maybe this would be a topic for some other session, but I just wanted to give a highlight of it. So to discuss about the things that we have been building, so the first thing that we built out is CI snippet libraries. A huge kudos to my colleague, Gaber, who has been working pretty hard on this. And he basically gave an entire overview about how it is like to integrate localstack into any of the popular CI providers. So if I switch to my other screen right now, maybe my documentation, I can get to see Okay, let me see if I can switch my screen. Okay, I guess I am having a bit of a trouble. Okay, in this case, I guess I cannot switch my screen to like some other tab for some technical reasons. Um, just give me a second. Yeah, sorry. Cool. So we have got the user guides right over here. And in this case, you can get to see that we have individual snippet libraries for different CI systems like Circle CI. We have things for Github-actions, for GitLab CI, Code Build, and Travis. So if you're using any of these CI providers right now, please consider like looking at these snippet libraries and just take references from them and see how they exactly work out. And then you can actually like use them in your local stack setup to make sure that everything is tested right on the CI runner itself. So switching back to the slides itself, the additional thing that we have got is that we have got the sample CI pipelines. So we really wanted to make sure that all of our CI samples are concentrated on one single place. So we picked up the serverless image resizer, which is one of the most popular sample applications that we have kind of built out. And if you go over to that repository, you can technically go to bit.ly/ls-ci-sample. And you can get to see like all of these sample CI pipelines over there, and you can get to see how you can really adopt local stack in similar scenarios. So this is a classic serverless integration that we are emulating right over there. So you can take some really good inspiration, or if you have got any questions, you can just reach out to us via our community Slack. So moving to the next slide, I guess now is the time that we really go deep into how you can easily get to work with a local stack on the CI itself. But let us first talk a bit about the target architecture that we have at hand. So in this case, we are getting to deploy a loan broker application. It's a pretty common enterprise use case that is quite popular, like amongst a lot of AWS reference guides and some online articles. So we kind of take up the same sample and we are using a bunch of different AWS services. Like we have got Lambda over here, we have got EventBridge, we have got a step function state machine over there. That basically allows us to send in a loan application, which in turn will retrieve the list of banks and just dynamically route the whole thing over there. So this entire application is deployed using CDK, both on my local machine and on the continuous integration. And in this case, I am joining using, like I'm using Github-actions as my CI runner, but you can kind of use the very same steps like in some other scenarios. Like for example, you can use Circle CI or Travis or something else altogether. Cool. So with that said, I guess I can look into how do I set up my CI workflow. So there are really easy steps in this particular case. So I would be setting up the local stack core cloud emulator. And for this to happen, I would be using the setup local stack GitHub action itself. The second one is that I would be, just give me a second, maybe I should be searching for set up local stack GitHub action. So yeah, I would be using the official GitHub action plugin that we have kind of built right now. Second, we are going to set up CDK and CDK local. So CDK local is a wrapper script that we have built on top of the AWS CDK library itself. And this just redirects all of the AWS API calls, not to the real AWS, but it redirects them to our running local stack cloud emulator. The third step would be obviously like deploying this whole thing like onto the local stack cloud emulator, and then using the PyTest framework to run a very simple integration test to just get a feel about how this application exactly is working out. So I'm switching to my VS Code. As you can see, I have already my CDK setup available right over here. This is a really simple one, and if you want to further explore it, you can go to this particular GitHub repository, which again is forked from the local stack samples itself. So I would switch back to my VS Code. And in this case, the first step that I can undertake is kind of starting my local stack container. So we made the local stack 3.4 release today. So yeah, I guess this is something that would be quite valuable for our community. And as I said, local stack start, this basically spins up the whole local stack Docker container. Once this is done, I can go ahead and I can first use the CDK local bootstrap. Bootstrap basically synthesizes the whole of the CloudFormation template that we want to deploy. And in this case, I'm also like specifying the AWS account ID, which is just default for the local stack over here, and also the region that I really want to deploy this CDK stack on. So as Lukas was showing you before, you can easily kind of abstract this whole command in some sort of a makefile target, like just make deploy, and that would bootstrap your environment, and that would just deploy your entire CDK stack right over there. The next step would be to deploy this whole stack. I'm specifying these couple of flags over here. Like I have got two CDK stacks over here, so I want to deploy both of them all at once. And I also am specifying that I don't want to like give an explicit approval for this, which is going to be useful for us in non-interactive environments like Github-actions, where there is no one to say that, yes, please deploy this environment. You really want everything to be done automatically. But in this case, like if you really want to try deploying this on the real AWS cloud, that will take you around 12 to 15 minutes at best, depending on like your network and like how close you're to the AWS region that you're trying to deploy to. But in case of local stack, that would take you around a minute or maybe a minute and a half or so. So this is just my local machine, but once you deploy this on CI, that would be even faster. But I'm going to show you how you can get even like better than that. So this is running right over here, but maybe I can take your attention off and just show you the GitHub action workflow that we will be implementing. So I have two workflows over here. I have got a main.yaml and a cloudpods.yaml. So let us first talk about main.yaml over here. So my stack is right over here, and it is traditionally doing all of the things. So it is deploying a local stack. It is getting triggered every time someone makes a push to the main branch or maybe make a pull request. And it is following up on all of these steps by using the GitHub Action marketplace items. For example, we have got the checkout that kind of checks out our code on a CI runner. We are installing Python because we are kind of pulling local stack directly from the PyP registry. We are setting up Node.js because we want to install the CDK library and the corresponding CDK local wrapper script. Then we're installing the dependencies, and then we start the local stack cloud emulator. So we're using the setup local stack GitHub action over here. And I'm specifying a couple of options. So for example, I want to use the latest Docker image in this scenario. And I also want to use the Pro image. So local stack Pro image basically contains all of the premium features. So things like EKS or event bridge pipes. But trust me, you can just run this whole application using the local stack community edition itself. So this is just a sample right over here. So I guess I should not do much of an ado, and I can just like commit both of them together. So I can say like I want to add a GitHub action workflow. I'm gonna discuss about cloudpods.yaml a bit later, but let us first push this right to the main branch. I know it's not a very good practice, but this is just for demonstration purposes. So if I switch back and maybe refresh this page once, GitHub is usually quick to act on this unless and until there is an outage happening. So you can get to see that our workflow has now triggered. This is checking out our code. This is installing all of the necessary dependencies that we require. So things like Python, Node.js, CDK, and the rest of the dependencies. So let's switch back to the VS Code again and see what we are doing in the next case. So we have additional step where we deploy our CDK stack just using the same commands that we have used on our local machine. And finally, we run a couple of integration tests using the PyTest. So if you want to explore how does the integration test look like, this is what we have right over here. So we create a couple of fixtures, and we basically trigger the step function state machine. And then we basically check for outputs to see that it is functioning in a fashion that we are expecting it to. So in an average scenario, this will take you around maybe 3 or 4 minutes to kind of execute the whole pipeline. And this is already like quite a good boost in comparison to deploying this whole thing on the real cloud. I'm just taking an example of how you can basically test an infrastructure without having to deploy on the real cloud. But what if you are dealing with an application where the infrastructure does not change much? And maybe you have like a separate front-end component, maybe a back-end component, and maybe some infrastructure that you're kind of testing repeatedly on, but it's not changing that much. And you don't really need to deploy this whole thing all over again just because you want to test that thing. So in this case, I'll switch back to my slides because I want to show something that's really, really fascinating. Uh, So there is room for further improvement. I guess like once I switch back my slides to the GitHub action workflow, you will see that this whole thing took about 4 or 5 minutes to kind of deploy. What if we kind of cut this whole thing down to maybe 2.5 minutes, maybe 2 minutes, maybe even less? I'm not sure about that. Lukas will have like really fascinating stories about cloud pods. So as I said, cloud pods, as I like to call it, it's Git for infrastructure. And just like how you kind of commit, push your like basically like how you commit and push your code to any remote repository, cloud pods allow you to save your infrastructure state into a pod that is stored onto the local stack web application, and which in turn you can basically share that with any of your colleagues. You can inject it or basically precede it on any of your CI runners, and you can have your infrastructure already right when the local stack starts. So in this case, you can actually use this one configuration variable called as auto-load pod that basically starts your local stack with pre-configured cloud pods. I am using slightly different option. I'm using like additional GitHub action plugin for this particular scenario because I just want to have control about which cloud pods I really want to load and things like that. Now, it has got three main benefits, to be honest. So the first one is that it cuts down your deployment time. When I was working with Lukas on the blog, he kind of told me that before it used to take about 1.5 minutes to deploy the whole local stack infra on GitHub action. But with CloudPod, that is cut down to just 10 seconds. That's magical. That's fascinating. Your whole infrastructure state can be loaded, can be shared, and can be injected anywhere at will, anywhere where local stack can run. The second one is that you can basically save your infrastructure state if the deployment fails. So just imagine I'm running my tests and there is a particular test that just times out or that just fails. The good part about this is that this whole thing is saved as a cloud pod once again. So you can pull that cloud pod just like how you do it with commits. So you can pull that cloud pod onto your local machine and you can really inspect about what exactly has gone wrong. Even better, you can even push your cloud pod into an ephemeral instance and then you can like start analyzing it in real time. And finally, this gives you a chance to version your infrastructure state, not just the state, but also the resources, which has got far and wide sample use cases. So maybe let me just pull back to the sample workflow. You can already see that my deployment using CDK is complete. This time it was faster, 2 minutes, 42 seconds, which is quite a surprise to me. Now it's running the integration test, which I hope should work out really well. It did work out really well. So let's pat our back for that. But if I go back to the actions tab, and as you might remember, I had another GitHub action workflow that I didn't like told you about before this particular slide, which is cloudpods.yaml. So I have nearly identical steps right over here, but instead of deploying my CDK stack manually, I'm kind of having this another GitHub action step that just says that, hey, I want to load this particular cloud pod right over here. So this one was created by me much before, and the way to create it is really, really simple. You can just go ahead, you can say local stack pod save loan dash broker dash infra. You hit on save, and if you go to the local stack logs, you will get to see that local stack basically saves the state of all of the resources that we have created. So things like DynamoDB, step functions, SQS, SNS, and all of that. And this basically push it to the local stack web application. So you can see like it has been stored on the local stack platform with all of these services right over here. And in this scenario, if you click on maybe not this one, maybe these CloudPods workflow, you will get to see that this one just took me around. Okay, so the name for this was wrong. It's not save the CloudPod, it should be load the CloudPod. But it technically took me just around half a minute to kind of load this CloudPod onto this GitHub action workflow. So this is already like a huge booster, maybe almost 4 times or maybe 5 times faster than that. I'm not sure about the math. But your infrastructure state is now all available, and now you can run your integration test without having to deploy your infrastructure state all over again. If you actually get to compare like how much time it took, so with the cloud pods, it took you around 2 minutes and 3 seconds. With CDK, it took you around 4 minutes and 21 seconds. CloudPods is not a replacement for CDK, but with the help of CloudPods, all you need to do is to kind of create your CDK stack, deploy the CDK stack onto local stack for the first time, save it as a CloudPod, and maybe you can configure another GitHub action workflow, which kind of creates a new CloudPod every time your infrastructure state kind of changes. So that basically gives you the latest version of your infrastructure that you can technically run your tests on. So switching back to the slides once again, yeah. So yes, with the help of localstack, you also have got access to another additional feature. We have got localstack-ci projects. You can also call it localstack-ci analytics. This is a pretty new feature that we rolled out to a few private users with the localstack 3.0 release last year. And we kind of demonstrated it at like multiple other places like AWS reInvent, for example. And this feature basically allows you to drill down into a lot of the things that you really want to know about your CI pipelines. For example, you really want to know about like the whole local stack logs and how did your application interact with the local stack. So you get to access that. You get to access the request response traces. So every time you're running an integration test and these integration tests are kind of hitting the local stack emulator, you can get to see like what was a request and what was a response and kind of see like, is it what you were expecting out at the end? With the help of CI projects, you get to save every CI run as a cloud pod in itself. So no worries about what if my CI fails. Everything is saved as a cloud pod, so you can just inject it back on your local machine or maybe an ephemeral instance, and you can get to use that right over there. And then you have got the stack insights. So with the help of stack insights, you have this whole observability layer where you see like, okay, how did your application interact with the local stack? What API calls were successful? What API calls were not successful? And so on. So if I switch to my like Chrome browser once again, I guess I'm switching. Yeah. So you can see like this is one of the initial previews for this whole feature over there. We kind of ran this integration test quite a long time back. And I'm just showing this like right from what we are dogfooding within our own platform. So you see like this is the whole log output that we have over here. And in addition, we have got these request response traces. So if you go ahead and maybe click on any one of them, for example, if you click on this one, okay, maybe not this one errored out. Okay, CloudFormation resources, I guess they took a lot of time, but if you click on this, you can see like we have got the DynamoDB service, we have got the operation, and then you see the request and the response trace over here. So things with Cognito, things with secrets manager, and so on. So this gives you a pretty realistic scenario about the whole local stack CI observability. And in addition, you can have like a tighter control over your entire CI pipeline. In addition, we also look into your individual tests that are kind of interacting with the local stack emulator. You can click on any one of them and you can kind of click on expand to get to see like how does the whole thing is exactly working out. So this is a pretty exciting feature. And to be honest, all that you need to do is kind of integrate this into your CI workflows once it goes GA, is to go to your CI workflow and maybe just add this one uh, env variable, and you can just mention like whatever project you're kind of using this whole CI project for. So yes, this is pretty much like how you can leverage the CI observability, and this is how much we are kind of fleshing out the whole CI support within local stack. So switching back to my slides once again. Yeah, so coming to what are some of the best practices. So the few things that I can recommend is that always try to utilize the state management tools. So never try to kind of like create resources manually using AWS CLI or something like that. Always try to use more efficient like ISC tools like Terraform or CDK, because that gives you like a tighter control over how your infrastructure is changing progressively over the time. The second one is that always try to leverage our tooling. We are kind of investing a lot of resources and time into building a much more efficient workflow that allows you to test your AWS applications reliably. So just get on using that. The third one is that always try to capitalize on the CI platform feature. So make use of various things like the caching, CI plugins, or marketplace items or artifacts, because we have been using them heavily, especially with things like Github-actions, and they have been like really working out pretty good for us. And finally, read the manual. Most of the time when I'm trying to fix CI issues, the answer lies directly in the documentation. So if you're running into any trouble, just read the documentation and you will be fine in most of the cases. So that was it. I hope it was informative for you. And thanks again for having me. And I would be up for questions now.
Yeah, yeah. Thank you so much, Harsh. I just wanted to add one more thing. I mean, the feedback that should also go in best practices. So if you're trying out the CI and you find any feedback on which we can work on, please tell us over the Slack channel, or maybe just add the issue over GitHub.
Yep.
Cool. So let's go with the question. The first question
Mhm.
is, will local stack emulate things like code build or code pipeline?
That's a pretty interesting question, I would say. I kind of smelt it like way back. So I guess like we have open GitHub issues for both of them right now. So the best thing that you can do is kind of go on the GitHub issues, just find the code build and code pipeline references, and maybe just put up like an upvote or maybe put up a comment that describes your use case and what exactly you're expecting out of an emulation for this. This has been on our radar for quite a long time, and we definitely want to build this out right in the future, but yeah, it's not on our roadmap currently as far as I know.
Cool. Then we have any better way of testing GitHub Actions with local stack itself?
I guess for GitHub Actions, we have a tool that's called as Act. It's by Nectos, and I did happen to use it almost 2 or 3 years back when I was working on SciPy, which is a statistical computing Python library. It worked out really well, and I would say like for small to medium scale use cases, Act will just work out pretty fine. There's no need to like kind of extend local stack to different use cases that the other emulators are kind of already solving right now. But that's my opinion. But yeah, you can definitely start using up Act to kind of achieve similar like testing scenarios.
Cool. Then we have this question, which is related to Bitbucket. So any
Mhm.
pointers when using Bitbucket and Local Stack Pro?
Yes, so Bitbucket has like this is something that we have been trying to build the support for, and I guess the main problem with Bitbucket is how you mount the Docker socket. So as you can see, like local stack works pretty well on VM environments like GitHub Actions, for example. But if you try to use local stack in certain scenarios where you really don't have the privilege to mount the Docker sockets, this is where things will get a bit problematic because local stack requires access to that. It should have the right permissions for it because this is what we use to kind of create compute resources like Lambda or ECS or EKS or things of that sort. So right now we are building like kind of like documentation for that. So I would just say like uh, make sure that you check it out once it is out. But if this is a persistent scenario that you are facing and you're really having troubles with that, just reach out to us on Slack, and we would be more than happy to set something really easy for you.
Cool. So we have what other CI platforms are supported?
I would say if it comes to official plugin support, it's only GitHub Actions and GitLab because it's really easy. You just like use a GitHub Action like marketplace stuff that we have, or you just use a Circle Say orb and you're all set. But as I said, LocalStack has a pretty generic driver, which means that all you need to do is download the Docker image, download the auxiliary tools, like do some networking caveats to make things work, and you're all set. That's the only thing that LocalStack requires. So it's not that complex overall. But we hear from the community that it's still like a bit of kind of going over multiple steps. So we are kind of simplifying the scenario right now. And I hope that the snippet library is kind of a right step in that direction. But we're happy to get any feedback on this whole thing. Yeah.
Cool. So we have this last question, Harsh.
Mhm.
I think it's a bit unrelated to CI, but again, I mean, this is one of the feature which we support, which is amazing.
Mhm.
So how robust is LS at evaluating IAM policies in complex situations,
Mhm.
like accounts, resource policies, and is there any coverage map for IAM actions?
Coming to the later part of the question, I'm pretty sure that there is no coverage map for IAM actions, but that's a good feedback, which we'll take and we'll try to deliver on that. The first question, so LocalStack has got this IAM enforcement feature. So basically all that you can do is set up this one enforce underscore IAM flag, and that would be like helpful for you to test your policies in multiple situations. But when it comes to things like cross accounts or maybe cross region or like resource policies, I'm not so sure about like how capable LocalStack can get. So I would just say maybe build out a really sample use case, like maybe a script or something similar, set up that flag, see how LocalStack works in that scenario. And if it does not, just let us know about this. We'd be happy to hear from the community and kind of work on the feedback.
Awesome. Thank you so much, Harsh. With this, we come to the end. We are over with questions. Yeah, so I just want to say, everyone, thank you. Thank you for watching. Thank you, Lucas and Harsh, for taking out time, prepare the presentations, demos. I mean, I think we had like 4 to 5 demos this event, so that's huge. And thanks to Lazar, who is our backstage person. So the experience was smooth, everything was smooth because of him. And lastly, I would mention that if you have any questions, any more questions, or if you have any doubts, you can join our Slack channel, which is slack.localstack.cloud. So, yes, with that, thank you so much. Have a wonderful day.